In this video, we will demonstrate how to use stepper motors and belts to move an electromagnet. We will be using two 12-volt stepper motors, two motor drivers, and one XRP robotics board that utilizes the Raspberry Pi Pico 2W. For the structure, we have some extrusions, belts, pulleys and idlers in Core XY configuration to allow for movement.
Let's go over the schematic. There's an XRP robotics board connected to motor drivers via the GPIO pins, and the motor drivers are connected to 12-volt stepper motors. The electromagnet is connected to a transistor, which is connected to the XRP board. A buck converter allows 5 volts to pass through when the XRP board sends a signal.
Next, we started assembly. Pretty quickly, we ran into a challenge. The first iteration of the wheels that were 3D printed for the side carriages of the gantry did not roll smoothly like we intended them to. We eventually decided to go with wheels that were V-shaped and printed in PLA, with a bearing press fit into the wheel for reduced friction and wear.
A problem that we had while trying to control the stepper motors is properly pulling the mode select and enable pins high or low on the motor driver. While in theory, some of these pins should be pulled to 5-volt or ground due to pull-up or pull-down resistors on the motor driver boards, we often had trouble unless we connected them to 5-volt or ground ourselves. Once we solved this issue, the rest of the assembly went smoothly. Now let's look at the code, starting with the portion that moves the gantry. Since our end goal was a full chess program, we created a well-organized gantry class so we could easily integrate it with other parts of the chess code later. We opted to use position-based movement for the gantry so that we could easily specify what coordinate we would like the gantry to go to, and it would move there regardless of current position. The function allows us to specify straight, rectangular, or diagonal movements. A challenge during the coding process was figuring out how many steps to move each motor. Since the pulleys, idlers, and belts are in the Core XY configuration, each motor contributes to diagonal motion of the gantry. To make vertical and horizontal motion, we activated both motors at once. By subtracting the vertical coordinate from the horizontal for the right motor and adding the vertical coordinate to the horizontal for the left motor, we converted a standard vertical-horizontal coordinate system to the diagonal coordinates of the Core XY system. This project has been a fun challenge for us. Make sure you check back to see the other pieces of this project, and check out the write-up on Maker.io linked in the description below.